In the last video, we went over some log rules. In this video, what I'm going to go over is how they're useful. So this is going to be usefulness of logs. Usefulness of logs. Logs are useful when we have a variable in the exponent. So say, for example, I have 3 is equal to 2 to the power of x. Okay? And I want to find out what x is. Now, since the variable is in the exponent, logs become incredibly useful. So you recall that we can basically put log, but we can also use ln. And I will just use ln just because that's sort of typically used. So what we can do is apply lns to both sides. So in other words, this becomes ln of 3 is equal to ln of 2 to the power of x. Okay? So what we can do using the log rules is we can bring the x down. So ln of 3 is now equal to x ln of 2. Okay? And if we do that, basically x is equal to ln of 3 divided by ln of 2. And if you recall what ln was just basically log base e3 over log base e2. And if you remember the change of base rules, we can just basically now eliminate the base and go backwards and say this is log base 3. Okay, I hope that made sense. If you just revisit the last rule, which was the change of base, we went from here to here. Now all I'm doing is just going from something like this to this. So you need to be comfortable switching forms for the change of base rules. Okay, so this is where how logs are useful, is that if you need to find the variable, which is the exponent, you have to apply logs, bring it down, and then therefore we can solve it. Okay, let me give you like a slightly more complicated example. So say, for example, it's 2 to the power of x plus 1 is equal to 3 to the power of x minus 2. Okay, so what we can do in this case is we can apply, now our variable is in the exponent, so we must apply logs to both sides. So let me apply ln 2x plus 1 is equal to ln 3x minus 2. Okay. What we do now is we can bring the exponent down. Okay. So then when you bring the exponent down, put it in brackets. Don't just put x plus 1. Put x plus 1 in brackets. So it's ln of 2, and it's equal to, we can bring this one down, so it's x minus 2, and it's ln of 3. Okay. Now, what we want to do is we want the x's. So what we have to do first is expand everything. So this becomes x ln 2 plus ln 2, because x times ln 2 is ln 2, 1 times ln 2 is that. This becomes x times ln 3, x ln 3 minus 2 ln 3. So just like any other sort of variable expression, bring all the variables to one side and the constants to the other. Right? So I'm just going to bring all the x's to one side. So I have x ln 2 minus x ln 3. And I'm going to move this ln 2 to the other side. So it becomes negative ln 2 minus 2 ln 3. Then I can factor out the x on this side. So I have x ln 2 minus ln 3 is equal to negative ln 2 minus 2 ln 3. Okay. The last step is we just want to isolate the x, so we divide. So x is simply equal to negative ln 2 minus 2 ln 3 all over ln 2 minus ln 3. And you can just plug that into a calculator and see what that equals. I'm not going to do it. But the point was, I just wanted to show you how we can isolate x and how logs become useful if, especially when we have our variable in the exponent. We have our variable in the exponent, and we need to basically use logs to solve for it. Alright, so in the next video, I'm going to show you the relationship between logarithms and exponential functions. So see you in the next video.